So that's what carries it forward. Okay? So if you look at this in terms of like the right-hand rule, so you have like a velocity, okay? And then you have like but here's the difference. You have an electric field and a magnetic field.
I got 2 fingers.
So you have a light going through like this, but then you have an electric field and a magnetic field. And those are always changing. So as you change one, it propagates a change in the other. And so it's going to go in this direction as those are changing as they go through. Now, the equation I'm going to give you, don't flip out. I'm never going to expect you to memorize it, but this is one of like the cornerstones of physics. So, no, it's okay, but it's cool.
What if it's over on this one? You just don't know it.
What?
Oh, what do you mean? Oh, this is that's the equation. Like we know. Yo, I've seen this since I was a kid.
Oh,
what do you mean?
That was childhood.
1 over 8.85 times 10 to the
Wait,
negative
what
second.
is the V stand for?
Wait, aren't those both constants?
I've seen that equation. I've seen that.
You not.
8.85. I'm pretty sure it's just negative 1 and 10.
Why are we making it?
Wait a second.
Oh, I know that one.
Oh, A. I've seen one before.
Yeah, negative 12.
Okay.
Minus 12.
So, if you look
Oh,
on
that's 4 pi.
this sheet of constants, you have right here in the middle, you have 2 different constants that need to become your friend. One is the vacuum permittivity constant, and the other one is the vacuum permittivity. So you have permittivity and you have permeability. So one is E naught or epsilon naught, and the other one is mu naught. So these are listed here. So if you do this math, and this is what James Clerk Maxwell calculated, and it was tough obviously to get these values, but if you do this math, if you take 1 over the square root of epsilon naught times mu naught, the permeability and permittivity constant, you get
No.
There's no
Speed
shot.
of light, bro.
No.
speed of light. Speed of light. So Clerk actually predicted the speed of light before they found it.
Yeah, why do we never talk about this guy, bro?
That's smart.
We're talking about it
Okay.
right now.
If I had talked to you before you studied electromagnetic theory about this, you would have been going, I don't know what's going on.
Well, we
Or
have
have
I know what's going
to
on.
handle this.
Okay, but we
I don't
would
think
have
I
known
am.
the speed of light is. You would have been like, oh, he knew like
That's why I read it.
Nathan, you moved the table again.
Is it?
I'm not even talking to you.
I'm joking, bro.
You can't just put it together.
Josh.
Huh?
Yeah, this calls for a beer.
Hey, that's why
I need you to get height.
Yep.
Okay.
You've never seen
Now, here's the other big equation that Clerk came up with. And that's if you multiply the speed of light, 3.0 times 10 to the 8th meters per second, by the magnetic field, you get the electric field. Pretty cool. Speed of light is a constant.
That's a lot of variables.
So what does that mean? As the magnetic field strength gets bigger, so does the electric.
I think we should know that.
What has to happen to
Well,
the
that
electric
works
field
Yeah, it's
strength?
funny.
It also has to be
Oh,
bigger.
it's only light? Yeah.
I can
Because
put
it's
the F
multiplying
with
it by
the
the speed
letter
of light.
So it only works
or
maths or
Oh,
something.
So obviously, if there's no electric field, guess what?
No magnetic field.
The equation collapses. So this is why you have to have electromagnetic theory.
Yeah.
So these two numbers multiplied
Kevin.
together always equal like a fixed value. But if you want to look at it differently, C equals E over B. If you do a little bit of rearranging. So the speed of light is a fixed value. So what does that mean about the ratio of your electric field to your magnetic
Oh,
field?
it's a fixed value.
It also has to be a fixed value. The values don't have to be the same, but the ratio has to be the same. So this was the beauty of James Clerk Maxwell, is that he predicted the speed of light before they measured the speed of light. That's so cool. It is. Okay. Now, other big equation. These we talked about before.
T equals MC squared.
C equals lambda times frequency. What's C?
Classic.
Speed of
light.
Speed of light.
Speed of light.
We're not getting there.
What's new?
What's new?
What's new?
What's new, baby?
Berg, what's new?
Or if you want to go
Still my
old
big mic.
school, lambda new. What's new?
Average.
Well, in this case, what's new would be
Oh.
C over lambda. Okay? Now, the other big one. You have E equals H new, right? Or HF. So, here's what you need to look at on this. So, if you go over here on this page, where you have Planck's constant, I need to explain why there's different things listed here. So, typically, Planck's constant is 6.63. They've left off the 4. That annoys me. Use 6.634 times 10 to the negative 34th joule seconds. What this gives you is the energy in one single photon. Okay? It's an extremely small number. So if you were to make popcorn, right?
Exactly.
Each photon isn't going to carry much energy. So what are you going to need to make popcorn?
A lot of them.
You need a lot of them,
Yeah.
because each one is going to carry a very small amount. So, now, if you look on here, this is one value for H. Now, you have another one, which is 4.14 times 10 to the negative 15 EV seconds. Anybody know what EV stands for? We'll talk about it
Electric
very
vehicle.
briefly.
Electron volts.
Electron volts. So electron volts are the voltage that you apply to an electron. Okay, hence the term electron volts. So here's your conversion down here. So down here, you've got 1 electron volt is 1.60 times 10 to the negative 19th joules. Oh, that looks like a familiar number. Because that is the charge. Okay? So 1 electron volt is the same quantity as a charge, but it's in electron volts. So this is why these two are equivalent. So if you're asked to find the energy of a light, a certain wavelength or whatever it is, you could either use HF, you could either use the joule second ones, or you could use the electron volt seconds. Okay? Just depends upon what you want to give that answer in. Typically, you use electron volts more often, mainly because of the fact that that's such a very, very small number. But that's why you have that on there. OP.
You answered my question.
Okay, never mind. Cool.
What's new?
Okay. Now, let's get intense. Anybody happen to remember the basic idea of how you calculate intensity?
Power over area.
Power over area. Power measured in watts. Area in meters squared. Okay? So, if you stand in the back of the room, why is my voice less intense?
Distance.
More area. Bigger
More
area
area.
still.
Because my voice is going to do what?
Spread out.
It's going to spread out. Power is a fixed value. You spread that out, you go further away, the area gets bigger,
Less
the
intensity.
intensity gets
My garage is
smaller.
open for
Which is why your remote control for your garage won't work in the school parking lot. You're still sending out the signal, but the intensity is so low by the time it gets to your house if you're in the
It's
school
been
parking lot.
it's been too
Wait, but I can
Now-
do it from my phone and
Oh, you don't know what that is.
I will never expect you to memorize these equations. They're in your book.
Yeah,
I just want you to see them.
see. Look, I can open my. Oh yes. Let's show zeros. I'll prove it. Does it show your garage opening? Yeah. If I click on it, it'll show arrows.
Biggie knot and little knot.
Oh, can you like not do
In the
that?
same equation.
Oh wow.
What is
Can we
that?
change what the letters?
Yo, class.
Wait, what is he writing?
Dude, everyone at my table is so stupid,
Knot is vacuum from the
Jack, I want you to think of this place as a
No,
library.
that's
Okay.
one of,
Oh,
that's
what?
one of, you
Oh,
don't find the
bro.
contact.
I can't hear what you're saying if these two are. Bro, it's being included so bad.
I'm done writing these down.
Okay.
Shush each other one more time.
Oh, it's
I can't hear what you're saying anymore,
Yes.
I understand.
Okay, so when you talk about intensity, there's 4 different ways you can calculate intensity. General one is power over area.
Sorry, it's fine.
And like I said, I'm just showing you this so you understand where it came from. So the other option is that you can use 1/2 c, which is the speed of light, epsilon naught, which is that constant, multiplied by the electric field squared. You can also use the speed of light divided by mu naught multiplied by b squared. And the reason that works is because of the fact that if you go back to this equation,
ratio.
yes, of E over E equals CB, if you do that substitution, that's where you get back to these, and these are all listed in your book. If you don't have them written down, don't flip out. They're all listed in your book.
The epsilon knot and electric field in the numerator.
Yes. So this epsilon naught, this mu naught is in the bottom. That epsilon naught is up top. Yeah, that's a 1/2 times that. All right, here we go.
I don't even know what I learned.
Oh,
What
yeah.
about the
know what I
end?
learned.
Wait, always forgets the end.
Hey, it's 4 button.
What you mean is so much out the
question.
25, bro? Question.
Oh, questions are like the outside.
Looks like he spelled questions with the W.
Oh, come on.
Yeah.
Whoa.
Oh,
He spelled his sign
I
right.
don't even know what I
Question
looked
for the W.
What am I looking at?
Birkham, hold on.
Right.
Hey, I'm not
Oh, chill out, bro.
Mr. Birkham,
What is-
I'm not gonna be here tomorrow, by the way.
Oh, they're multiple choice, aren't they?
Also.
They better be.
Hopefully.
I'm going to
25
Aren't all the
minutes.
ones in the back of the question section? 31
Wait, 29. How did it jump to 40?
No, you guys need to calm down.
It's at 42.
You don't care.
Oh, okay.
Yeah. Hey, you're gonna get a noise complaint real soon, pal.
Hey, good job, Ray Leader. Why do you have that?
16.
Holy-
That's
now we're done.
16.
Why do you have
Oh, gambling gets a score. You got
Oh, that was hard.
That's a shot, right?
That's why I ran out of school. I thought you were gonna come.
Man, that was a shot across the bow there, Nathan.
Dude, he started laughing when you left.
Did you?
Yeah, a lot of you haven't handed in that lab final with the magnetic field.
Oh, did I hand that in, Mr. Birkham?
I don't remember. That's why I didn't even bother to grade it, because only about half.
I think I did. Hang on.
We're still on the
Why?
same.
Wait, why is it 4 pi squared on?
Because that's the area of like a point source going, I'm sorry, that's 4, I bet, screwed that up. It's 4 pi r squared.
Yeah, I'll look for it. I want to see.
My bad.
Is
Like,
that like,
What is that arrow?
is that like how, like you just thought we had like your ear
The
down?
intensity.
Huh?
Like your ear down, it's like 4
Like the
pi
P
r
over A.
No, that's just pi r squared, because that's a circle. This is like the area coming out of like
Oh,
a
so
side.
the area part is
Oh, so if it's probably
pi r
like
squared.
Yeah.
4 pi r squared.
Now I notice it.
Are we doing this?
No, you need to read
What?
it.
Salem
Don't
Witch
look
Wait,
Trials
when
is
is it
not
4 pi r
fake.
squared?
Don't look at me.
What do you mean it's not fake? Why was the Salem Witch
I
Trials?
don't know, I don't
No,
think
not
so.
like the actual thing.
No, it's not fake.